All right, we're going to do two graphs in a row. One is an absolute value graph, and the other has an exponent on it. So this is where it's very important that you also pick negative values for x. So I typically always pick -2, -1, 0, 1, and 2, unless I'm dealing with fractions like that one earlier. So that's what I'm going to choose here. So x values, I'm going to pick -2, -1, 0, 1, and 2. We're going to figure out y values, the answers, when we put those in, and then we're going to turn those into coordinates. Let's see, absolute value of -2 plus 1. Absolute value of -1 plus 1. Remember, we're putting these values in for x. So absolute value of 0 plus 1, absolute value of 1 plus 1, and absolute value of 2 plus 1. So in the earlier video I said be careful because sometimes you'll see a pattern, but you can't just automatically assume that that's going to continue. The absolute value of -2, remember, is the distance from 0. How far is -2 from 0? 2. Plus 1 is 3. Absolute value of -1 is 1. Plus 1 is 2. Absolute value of 0 is 0. Plus 1 is 1. So you're like, oh, 3, 2, 1. This is probably 0 and -1. And that would be like a pretty safe assumption. However, what's the absolute value of 1? 1 plus 1 is 2. What? Absolute value of 2 is 2 plus 1 is 3. What? So these coordinates, our input was -2 and our output, our y value is 3. Here we put in -1, got out 2. We put in 0, we got out 1. We put in 1, we got out 2. We put in 2, and we got out 3. So absolute value graphs you're going to see actually take a V shape. So if we were to plot these points, -2, 3, -1, 2, 0, 1, 1, 2, and 2, 3, you will see that is the V shape that we are looking for. Remember, take these, throw an arrow through them, indicating that it does go on forever in both directions. Now, I would love to do this with a ruler on the board, but when I do that on the board, it starts marking stuff up. But if I was doing this on a sheet of paper, like you should be doing right now, I would use the straight edge of like a folder or calculator or even a ruler, anything that has a straight edge to make a nice straight line, to make it really accurate. Now we're going to try one with the x squared. I'm going to pick the same values. This is called an exponential graph. It's got an exponent in it. -2, -1, 0, 1, 2. We're going to solve it, and we will get coordinates. So let's see. -2 squared plus 1, -1 squared plus 1, 0 squared plus 1, 1 squared plus 1, and 2 squared plus 1. Whoa, what happened there? What in the world happened there, Mr. Blank? 2 squared plus 1. Alright, here we go. When you square anything, it comes out positive, right? -2 squared means -2 times -2, which is +4. Plus 1 is 5. -1 times -1 is +1. Plus 1 is 2. Don't do the pattern thing on this one, because 5 down to 2 is like down 3. Then you'd be like, oh, -1, -4, -7. Doesn't work on these. That works for what's called linear graphs, but this is an exponential graph, so that doesn't work here. 0 squared, 0 times 0 is 0, plus 1 is 1. 1 squared is 1, plus 1 is 2. 2 squared is 4, plus 1 is 5. So let's get these as coordinates. When we put in -2, we got out 5. When we put in -1, we got out 2. When we put in 0, we got 1. When we put in 1, we got 2. When we put in 2, we got 5. So we plot these, -2, 1, 2, 3, 4, 5. -1, 1, 2. We got 0, 1. We've got 1, 2. And we've got 2, 5. So absolute value graphs came out to a perfect V. These exponential graphs will have a curve to them. They come out like a U or sometimes an upside down U. So show the curvage on this. You're not going to want to try to use a straight edge on this. And the curve's going to get steeper and steeper as that graph climbs. But we don't, I mean, if this graph went up to 100, it would be like almost straight up once you get up there. Pretty wild.